Hi, my friends, welcome back. Another live stream today where I'm going to teach you many topics about hardware, about how to repair efficiently motherboards. Okay, so my friends, in this live stream, we're gonna see basically the charge IC based on one comment of one of my followers about the charge IC, the most failed component on motherboard charge circuit. I'm going also to teach you about the double diode. What is the purpose of the double diode in the motherboard, and also how to test it based also on another comment of one of my followers. Also, we're gonna see how input switches are controlled or gated. And of course, from time to time, I'm going to teach you how to read schematics. So one of the most important live today is today basically. So let's get started. I'm going to wait 1 minute and then get started. Okay, so let's get started, my friends. I'm going to teach you right now how the charge circuit on laptop motherboard works. So this course basically is based of one comment of one of my followers. So let's get started. So guys, I'm going to teach you the short circuit here theoretically, and also we're gonna see the motherboard, not just the motherboard, we're gonna see this motherboard and other motherboards. So I will make it easy for you guys. This is the only video you need to understand 100% the charge circuit and how it works. So we're gonna see the theory part and also the practical part. For the practical part, my friends, so let me grab here a motherboard. Okay, so for the practical part, my friends, I'm going to teach you basically the components. Okay, let's make like this. Okay, my friends, for the practical part, I'm going to teach you the component near to the battery connector, what is its purpose, how to test it, the voltage here, and the most failed component, and how to resolve charging issues, etc. But let's first see the theory parts. So basically, my friend, sorry, we have the IC. Let's put the IC here in the middle. Let's name it this IC charge IC. Okay, in the middle here. Here basically we have the charging port. In this side, my friends, we have the power jack, or let's see the charging port. Okay, the charging port basically has many pins. Let's see here connected to the ground, and we have the high pin here. This high pin basically, my friends, is connected. Sometimes it could be connected to a fuse, okay, F, but sometimes it could be connected to inductor, or sometimes we can find diode, protection diode like this. Okay, my friends, but let's see a fuse. After that, of course, we have the switch. Depending on the type of motherboard, we can find, this is basically Q or switch, the first switch, or we can call it also FET. The first switch basically, usually we find in channel switch. Here we have drain, here we have source, and over here we have the gate. So for some motherboard, we can find just one switch, but for others, we can find basically two switches. Okay, we can find basically, my friend, two switches. The second switch here. Please pay attention. We're gonna see this here theory in the theory, and we're gonna see the motherboard also. So we have the switch basically here for in channel. As I told you, it could be the N channel used here or P channel, but usually we use N channel. Okay, this is for the switch. The switch, basically, my friend, is always connected to a current sense resistor. Okay, we called it current sense resistor, or simply CSR, current sense resistor, or current sensing resistor. Okay, after that we will get what we need. What exactly? We will get B plus. Give me please just 1 minute to see if I have a red pen. Sorry, my friends, I will use this one. I didn't find the red one. Okay, so we will get here B plus. Okay, this is B plus. This is the main voltage, the most important voltage that is used to power the whole motherboard. Okay, just please stay tuned. Okay, so in this side, so here we have the power adapter. Here, basically, let's say one of the most component or the important component in charge circuit, this one, the charge IC, and in this side we have what? We have basically the battery connector. Let's see like this. We have overhead the battery connector. Okay, this is BAT connector or CN. Okay, this is the battery connector, my friends. Okay, so now we get the P plus. My friends, we're gonna see all this in the motherboard. Just stay tuned, be patient, and we're gonna see everything. Okay. After that, we need here for the charge IC, we need here two MOSFETs, basically the higher MOSFET of or high fit. Let's call it high fit this time or high MOSFET, and we need another lower MOSFET or low fit. Okay, okay, my friends. Here, basically, for this one, this MOSFET, its drain, okay, the drain for this MOSFET is basically connected to what? Connected to always or usually we find ceramic capacitors here for filtering purposes connected to the ground, and this one connected to B plus here. But let's see, here we have extension, here we have B plus, basically the same as this one. And of course, the source here of this one will be connected to the drain of this MOSFET. Okay, the gate here will be connected to the IC. Okay, because this is the control IC. For this MOSFET, the source will be connected to the ground, and the gate also will be connected to the IC. Here we have lower, here we have the higher gate. Good. This one we have Q1, we have Q2, we have here Q3, here Q4. Nice. So guys, here of course, connected to the IC, here we need inductor coil for filtering. We need coil, of course, and of course we need also a current sense, another current sense resistor for the battery, okay? Another C current sense or sensor resistor, and of course we will need here some capacitors. Sometimes we can find, of course, ceramic capacitors, not polarized capacitors. Sometimes we can find polarized capacitors. And then, of course, we will get what? My friends, we will get, let's make it like this. We will get B or BAT plus. Okay, we will get BAT plus or the voltage for the battery. Okay, good. But we need something else, is the MOSFET, the battery FET or MOSFET Q5. This one basically is connected to the battery. Okay, it is connected, of course, to the battery here. Okay, and this one basically is used. Let's see, here we have source. Okay, and of course we have the gate. You get, of course, this one also is controlled by the charge IC. And this one, guys, also the drain of this IC is also connected to this line or power line or power rail B plus. Because when the adapter is removed, this is the battery will feed the motherboard. It will generate B plus. Okay? And of course, for the motherboard, the charge IC, it has many inputs and outputs. And also here, the most important, it needs the VCC. For the VCC is the working voltage. The VCC basically come from the VN, come from here, VN, okay? We call it VN, or from BAT plus, or from the battery. That's why basically for the VCC to feed the charge IC, we need what, guys? We need basically a diode or a double diode. We need here a double diode. Let's make it like this, for example. This is basically double diode. I'm going to show you all this. For this double diode, my friends, connected to the VCC, it can be powered by B plus, okay, or this one, BAT plus. Okay. For the double diode can be powered by B plus or BAT plus in order to power the charge IC. Let me please, I will show you right now, before continue, I will show you right now the double diode. It looks, how it looks like in the motherboard, and I will show you how to test it. Okay, my friends? So let's do it. Hi again, my friend. So I'm going to teach you right now how to test double diodes. This is basically the double diode that power ICs. What I mean, we find basically this kind of diodes, as you can see here in the multimeter, my friends. Please pay attention. Let me adjust, zoom in. Okay, like this, I hope. So as you can see, my friends, we have here diodes, 3 double diodes. This is the first one. Here we have D. This is basically double diodes. I'm going to teach you how to test it and what is the working principle of this diode. So let's grab the multimeter and begin testing the diode first. Okay? But let me show you very fast what is the purpose of double diodes. Okay, double diodes. Okay, my friends, we find double diodes basically This is the symbol. Okay, this is the symbol. We have here 1, 2, 3. Why exactly we use this kind of diode when, for example, we have the output? When, for example, an IC like this one require voltages or power from two inputs, here we have input 1, here we have input 2. For example, for the charge IC, it can be powered by the adapter EDP, okay, powered using B+, okay, or it can be powered by the battery power, BAT+, okay, my friends, BAT+. So that's why here we need a double diode. That's why we use this kind of diode, but we have always the same output, and here basically we have the IC. To power this IC, we have here VCC. Okay, my friends? So now let's test the diode, the double diode right now in the motherboards. So of course, to test the double diode and diode in general, we use, as you can see, the diode option. We use diode option, okay? So we select the diode option. Let's right now look for some diodes. Here, for example, okay, let me make it zoom in a little bit like this. Okay. So we have the diodes, guys. This is not a transistor. This is not a MOSFET. Even if we have 3 terminals, this is not a MOSFET. This is double diode. So to check this diode, we need just to set the multimeter to the continuity option, okay, to the continuity option, and then, okay, and then the black probe here in the pin number 1 here, the red probe here. We have to get same reading. Let's check. We get 560 here, and also here 500, as you can see, 25. Okay, 560, 525. Good. Means the two diodes inside it are good. Let's check this one also. So 560, 523, this one also 550 and 524. So this is a good double diode. Do you see, guys? Please pay attention. Okay, let me zoom out a little bit. Okay. So if you pay attention, my friends, okay, let's make it like this. Do you see, my friends? A double diode with a single input. Do you see? We have output. I mean, here we have output, but here we have two basically inputs. Two inputs for this one, two inputs for this one, two inputs. Do you see for this one, guys? two inputs, one input coming from here, another input coming from here, but we have one output. For example, if we assume that this diode feed the charge IC, this input, for example, coming from the adapter, and this input coming from the battery, from adapter, from battery, we will always get the B plus. If we use the adapter, we will get B plus. But if we remove the adapter and we use the battery, we will get B plus. That's why this is how the double diode works. It's different from the MOSFET. Please pay attention. It's different from the MOSFET. Even in terms of testing, it's different from the MOSFET. In testing, we find two readings between this pin and this pin, and also the second reading this pin and this pin. But for the MOSFET, we find just one reading. Okay, my friends? So let's even make a difference right now between double diodes and MOSFET in terms of testing. I'm going to show you right now, my friends. We need here, I need from you to understand 100%. So let's make it easy for you, especially for beginner. So the multimeter in the continuity option. So let's try this. So guys, the first, okay, zoom in a little bit like this. Okay, my friends. So this diode here, we have a reading with the first pin, another reading with the second pin. Okay, we have two basically readings, same readings, because we have two diodes inside it, as we have seen here. Okay, two diodes inside double diode. But for the MOSFET, my friend, different. We have just one diode. Let's see a MOSFET here, and let me look for a MOSFET and check it. For example, my friend, here we have some MOSFETs over here. All those are MOSFETs here. All those, we have Q, all those are MOSFET, my friend. Let's test this MOSFET right now and know the difference basically. Okay, let me adjust a little bit the multimeter and the motherboard, because as I told you guys, live is not like editing, making a video and make editing and all this stuff. Live, you have to deal with everything. That's why, guys, I deserve more likes. Please, more likes. For anyone who doesn't hit the like, please like if you enjoy the content. Thank you very much. Of course, you are free. And of course, for anyone who can share this live stream with others, I appreciate that. So, my friends, we check diodes, and as I told you, for MOSFETs, it's different. Okay, let's check those MOSFET, for example. Okay, so if I put one probe here in this side, okay, and let's check this pin from source to drain, we get a reading, my friend. From source to drain, we get a reading. But from this gate to drain, nothing. Do you see, my friends? Nothing. Here we get, oh, wow, zero. We get zero. Why? Is it a short? No, my friends. I touch the gates. This is also another kind of testing that you can use. You see, if you want to check if the MOSFET is serviceable, try to touch the gates using the red probe and then check between drain and source. You will get a beep. And after the exact reading. Okay, my friend, this is another test, and basically this is the most reliable test for MOSFETs. Okay, so for MOSFETs, my friend, you can test it using by putting the black probe here in the drain and the red probe in the source, you get a reading. Good, we get 500. This is good. But if you want to double check, okay, by checking the MOSFET like this, my friend, 80% the MOSFET is good. But when I touch the gate using the red probe, I inject a little bit current here, so I will get a short. Do you see, my friend? This is a short, but about just 2 seconds. Okay, so this MOSFET is good. Let's check this one also between drain and source. We get a reading about 500. Okay. If I inject a little bit of voltage here in the gate, I have to get short. Okay, let's repeat again like this. Okay, check. We get same reading. Basically, some MOSFETs can be blocked. It could be blocked. It could be work. It could be good, but intermittently bad. It could work intermittently. Let's check this one, for example, this one also. One probe here in the drain, one probe in the source. We get a reading 500. Good. This is good. But let's inject a little bit current here in this gate over here. Okay. Let's check, recheck again. Okay. This one is good. 100%. This one is good. This one also. We have 500, about 500. If we inject here in the gate, we have short. This one 100%, but this one, let's check this one. From drain to source, we get a reading. Let's check. Okay. From drain to source, we get a reading. Let's inject a little bit current in the gate. Recheck. We have 500. This one, is a little bit. I'm not sure if it's good or not, but it passed just the first test. The first test is this one. The first test for MOSFET is getting 500 reading, but the second test is by connecting the red probe to the gate and then get a beep like this. About 2 seconds, the beep disappears. This is the second test for MOSFET, but this one, it passed just the first test, not the second test. So basically, my friends, this is how you can test the MOSFET. But as I told you, for diodes, double diodes, different. We get here, my friends, 2 same reading. Okay, 2 same reading. Let's see. Okay, again, 540. This one also 540. It doesn't contain a gate. This one doesn't contain the gate. You see? If it contains the gate, I will get a beep. You see 2 diodes inside it. So in terms of testing, different from the MOSFET that contain the gate like this. So I hope, my friends, that you understand what is basically the purpose of the diode, double diode, and the purpose of the MOSFET. Let's break it down for you, especially for beginner, using theory, and go ahead with other basically information. Okay. So my friend, for double diode, I told you that this is its symbol. Okay, we find some same reading here. Between this pin and this pin we find about 540. Okay, drop voltage, and between this pin and this pin we find also 540 drop voltage. Okay, for double diode. And I told you that the W diode is used when the inputs are two inputs. If the inputs are more, we can even use another double diode here, another double diode like this. If, for example, we have 4 inputs, okay, we can use another double diode, okay, like this, my friend, with another output, basically the same output, okay, but we have, for example, this is the first input, this is the second input, this is input number 3, and this is input number 4. So we have, for example, 4 inputs from 4 different sources, but we have the output, we need just one output. Here basically we called it a duplicated outputs. This is for example, we use this for safety, okay? But in the motherboard, we find, of course, a duplicated inputs. But in other motherboards, in other laptop enhanced and improved laptop motherboards, you can find also 2 double diodes next to each other in order to generate one output to power an IC. It could be charge IC, it could be CPU IC, RAM IC, etc. But my friends, for the MOSFET, it's different. The MOSFET, basically, we have the gate like this, okay, my friends? We have the drain and we have the source. And we have a diode here, basically, let's say, sorry, let's use another color. And we have basically here a diode like this, as you can see, my friend. So when we check between source and drain, we get a reading about 500 drop voltage. But when we touch, okay, when we touch the gate like this, when we touch the gate using the red probe, okay, we touch the gate using the red probe here, we inject a little bit current, okay, we inject a little bit current here, we get here continuity, my friends, as we have seen in the motherboard. So for the MOSFET contain 1 diode, for the double diode contain 2 diodes. So I hope that you understand the difference between double diode and the MOSFET. And of course, thank you for one of my followers that asked me. This is basically, my friends, all topics that I discuss and we study in live streams are based on my followers. I always do my best to read your comments, and when I catch or I find a good comment and a good question that deserve studying, I try to study it. I hope that you understand. Please tell me in the comment, did you understand the difference between the double diode? Why exactly we discussed this one? Because 2 of my followers, one asked me about the charge circuit and the other asked me about the diode. And fortunately, in the charge circuit, we have the double diode, because in the charge circuit, my friends, always there is a double diode here that power the charge IC, the VCC, and the inputs are different. One input from the adapter, and this input, my friend, from the battery here. You see, 2 inputs, one from the battery, from adapter. When the adapter is connected, the battery is eliminated. When the adapter is disconnected, the battery take the charge and send the VCC to charge IC. That's why we use the double diode, my friends. This is the symbol, and of course I show you in the motherboard the component. So please, did you understand? Because we will move on to other thing. Okay, but please, before reading some comment, let me please see here if we miss something. Okay, we have power jack, we have the fuse for protection, we have here basically the two MOSFET. I told you in some motherboards you can find just one switch. We have the CSR or current sense resistor or current sensor resistor. It basically measure this. This basically current sense resistor is connected to the IC, my friends. It is connected to the IC here. It sense and measure the amount of voltage consumed by the whole motherboard. Also in the next to the battery connector, we have the CSR. I can even show to you, my friends, these two current sense resistor in the motherboard. Sometimes we find, okay, sometimes we find basically R, okay, R, okay, this one is bad. Let's use this one. We find R010 or R020. Let's see the motherboard, guys. You see, my friends? Let's take this one, for example. Okay. You see, my friend? Here we have the current sense resistor. We have the second one. The big one, always the big one, is for the motherboard. Here, the big one connected to the power jack. Here we have the power jack, we have the switch. Okay? And this switch is for the battery. This switch is for the power jack. This current, the CSR, current sense resistor, measure the whole current consumed by the motherboard. And this one is for the battery. Also, we have here R020. And of course, to test it, for beginners, to test it, you have to find about 1 ohm or 2 ohm. We can even test it, no problem. No problem, just for beginner. Let's put the multimeter. Okay, the multimeter to ohm option. Let's select 200. Okay, my friends, 200 here, and then check these two current resistors just to master testing. Okay, let's check. I have the multimeter, one probe here in this side, the other probe in this side. We get to 1.5. Do you see, guys? One. Okay, one. Let's check this one also. One probe here. Okay, one probe in this side, the other probe in this side. We get to 1.5, 1, 2, no problem. Okay, my friends. So these two consensus are good. But if you get one like this in the multimeter, means these current sense resistors are open. You have to replace it. If the current, guys, if pay attention, if the current sense resistor is open, the motherboard will be dead motherboard. Okay, and also in many cases, my friends, the charging issue when the battery is not charging due to the current sense resistor. To open the current sense resistor, of course, it is I mean, reliable, and it doesn't fail a lot, but sometimes if it fails, the battery will not charge, and also no charging battery, and also dead board. When you use the battery, the motherboard will need to be powered because of this current sense resistor. So I hope that you understand. So let's pass to another topic. Guys, don't forget to like, please. Let's see now some comment and then go ahead with another topic. Okay, my friends, I will see if I have a question in the comment and then continue studying our topics. Okay, so let's see if I have a comment here. Okay. Excellent work, my friend. Keep it coming. You deserve a wider audience. Thank you, my friend. Continent 5 Films. Thank you very much for your support. I appreciate that. Okay, Rondo Ilob. Good afternoon, sir. I have a 1013 desktop that have no responsive touchscreen. Please, can you help me fix it? No responsive touchscreen, my friend. So you have to check the connector, the touchscreen connector. If the touchscreen is good, is serviceable, not damaged, okay, you can just check the connectors, the connector, my friend. So in this case, you have to disassemble your scope and check the touchscreen connector first. The first check. AB film, please make video on mobile board check test. Okay, noted. Albert Jara, thank you for taking the time out of your day to teach us new there that want to learn more about electronics, how to fix computers. Thank you. You are very welcome. It's my pleasure. Albert's another comment. Jara, yes, you explained it good. Thank you. You take the time to explain to us. Thank you, Albert, my friend. Thank you. Free MPS TV. What about R005? Okay, R0. Yes, yes. Okay, Mr. Free MPC TV. What about R005? So I know that you mean the SCR, the current sensor resistor. Sometimes we find also R005. Okay, sometimes we find R005, my friend. Sure. Let's see another comment. Kwana dies. Nice work, brother. Thank you, brother. Uganda, Shivanda, something like that. I'm sorry. Very good, my friend. Thank you. Epson, God bless you for the big job are doing in each and every video. Thank you very much. And that's why, guys, your likes, your good comments help me and my team to create more videos for you. And of course, the thing that helps and that motivates me and my team, of course, is your likes, your good comment, your support. That's why we do videos and new content in a daily basis just to satisfy you and to basically to share the knowledge we have. And of course, with a minimum tools and minimum resources. So the guy who follow electronic repair basics ERB channel can work even at home because we use just the multimeter and we use the knowledge. No, you didn't. I mean, nothing else complicated. Very basic. That's why here we have basics, guys. This is electronic repair basics. We teach you basics, and of course, we discuss basics here, and you can do here. I teach you even at home. You can deal with your laptop or with your device. And of course, we always do the best to share the knowledge, the unique knowledge that is not available. Okay, another question from Uganda. Is it possible you make the drawing from all the circuits in the board? I like it how you explain. Of course, my friend, I can do all drawing from the board. I can just watch the board, watch the circuit, and do the drawing. I can even do it like now. If you enjoyed, Mr. Uganda, do you want to do it right now? No problem. Just in 10 minutes, I can draw the drawing for all circuits in motherboard. I wait your comment. I can do it for you, my friends, and for other followers. Let's do it. But I will wait your comment. And to hit the like. But I have just 80 likes. I want here, let's see, just 25. Okay, just 25 likes, and I will do it right now. 5 circuits in the motherboard, CPU circuit, 3 volt, 5 volt circuit, charge circuit. We do it for charge circuit. It's good. It's done. I will do the schematic for CPU circuit, for 3 volt, 5 volt, for RAM circuit, for all circuits in just 10 minutes. Here in live, no editing, nothing hidden. Waiting for your comments, Mr. Uganda. Okay, the same. Okay. Free MPS TV. Can you talk about voltage injection? When and how to inject voltage? Okay, another topic for voltage injection. Basically, it's not voltage injection, it's current injection, but this is a mistake or a public mistake or a current mistake. A voltage, we don't inject voltage, basically we inject the current. Okay, my friend, I will do it. Basically, in the live yesterday, I explained to you how voltage injection or current injection work. If you go to yesterday live, you're gonna find the explanation. Uganda, the same you are doing, but with all circuits, including RAM and CPU, all. What are the major faults that cause these motherboards? What are the major faults that cause these motherboards? Good. I like this comment. Okay. I will not this comment. I like it. This is another topic. Okay. Do you see, guys? From your comment, double diode using and testing. This is just a not double diode. Why we use it and how to test it. From comment from one of my followers. Now from free MPS TV, what are the major faults that cause this motherboard? Okay. Or let's say the most common faults are also major faults that cause these motherboards. Okay, my friend, this is another topic. I'm going to teach you this topic tomorrow. This one is for tomorrow. Okay, my friend, this one is for tomorrow live. Tomorrow live, I'm going to teach you this one. Or if we have time today, but today we're gonna deal with Uganda comment about schematics, all laptop schematics, how to draw it from the board. Let's see, we have other 2 comments and then back to the work or to the deep work. Okay, Albert Jara. Yes, free MPS, good question. Okay, Alexander Luis, please, I have laptop HP Pavilion G7, it is not shining, and beside the charging port a circuit that is very hot. Please, sir, help me with this, with some solution. Charging, and beside the charging ports, a circuit that is very hot. Okay, let's, guys, let's help Alexander Lewis. Let's help it about this issue. Basically, my friend, if you understand this schematic, please attention, Alexander Lewis, attention please. If you understand, my friend, the schematic, here we have the battery connector, okay? Here we have the battery connector here. This is the battery connector. So you say that next to the battery connector you have problem. What is exactly the component here that can be failed? The charge IC. This one, my friend. It could be the two switches. Okay. Let's also use the motherboard in order to understand very clearly. So guys, we're gonna discuss right now one comment from one of my followers that asked me, that has a laptop, basically HP Pavilion, that is not charging, and beside the charging port, okay, is very hot. Okay, let's discuss the charge circuit or the battery circuit, okay, and then continue with Uganda about drawing schematics, and then after that with free MPS about the most common fault. I hope that we have time to do all this. Let me grab a motherboard, my friend. Okay, I'm going to show you about 2 or 3 motherboards that I have here. This one, for example, my friend. So if you understand the working principle, that's it. No problem. You didn't want to understand the same board, just the working principle. We have the, as you have seen, or as you have mentioned in the comment, something is hot here. What you have here, my friend, the first here is the charge IC. Here in the back, we have the charge IC. Okay, my friend, here in the back, we have here the charge IC. So always attention to the charge IC, because this one could be the failure. The charge IC. Exactly as I have here. The charge IC first. Then MOSFETs, especially this MOSFET that is connected to the ground, could be failed. So here basically we have MOSFETs. We have this one and this one. Okay. Do you see the current sense resistor, the CSR? This one, this no, it will not be failed. This one will not be failed. Okay, and you have these capacitors here. Attention to this capacitor. Do you see his thermal capacitors? Those capacitors here, one of them could be shorted. Those could be shorted. Those are inductor basically. Let's see another motherboard just to understand. Same, my friend, but please pay attention. Here, also, this MOSFET could be failed. But this MOSFET, if it's failed, this MOSFET basically is not connected to the short. I mean, this MOSFET is not connected to the ground. So this one is excluded. Here, always you have to check component connected to the ground. And what is the component connected to the ground? those, my friend, the capacitors connected to the ground. Okay, this no, this good, nothing here. This one connected to the ground. This one also could be failed, yes, if these two could be failed in the same time. And this one is connected to the ground. Always the IC connected to the ground in many pins. So IC, MOSFET, capacitors. Okay, my friend? Or if you have here, if here you have a bad connector or a shorted connector. Here, for example, let's see this one here. Okay, we have a battery connector over here. We have the battery connector. Do you see the battery connector? We have the two switches here. The two switches, and we have here B plus. This is the input. Okay, two switches. These switches could be failed. We have the charge IC could be failed. And in this side, we have a protection diode. This one could be failed here. This one also could be failed, and serum capacitors here in the output could be failed. So this is it, my friend. Easy. So, Mr. Alexander, check charge IC MOSFET ceramic capacitors. Charge IC MOSFET ceramic capacitor. That's it. And of course, in the output also could be failed. Those also, if shorted, you will get something hot next to the battery connector. So let's, right now, my friends, let's go to deep work and go to Mr. Uganda Shivanda like this, that say to me, is it possible you make the drawing from all the circuits in the board? I like it how you explain. Let's do it right now. I have many other topics, but let's do it for Mr. Uganda right now, my friends. Let's do it. Oh, I forget the mic. Sorry, my friends. Sorry. Okay, let's do it again. No problem. I will do it again for you, my friends. Sorry. Okay. First, tell me what we call this. This one that we use for water. I will do it for you, my friends. Don't worry. Let me grab another paper. Okay, this one. Okay, my friend, the 3-volt, 5-volt circuit. Okay, the mic, 3 volts always, and 5 volts always. Okay, my friends, we have the IC. Okay, we have the IC here. Okay, so this IC will generate, basically, we have the coil, and here we will get 3.3 volts. Here we will get 3.3 volts always. Okay. Here also we have inductor, and here basically we will get 5 volts always. Okay. So guys, if you understand the 3-volt, 5-volt circuit troubleshooting, what we have inductor here, let's see L1, L2, and that after that, of course, let's deal first with the output. In the output, we have, you can find ceramic capacitor, we can find an electrolytic capacitor connected to the ground here. This is for filtering. Okay, we have inductor. We have here 2 MOSFETs, Q1, we have here Q2. Basically, Q1, my friends, the drain is always connected to 3 ceramic capacitors here, and those connected to what? Connected to B plus, my friend, B plus, the main voltage, and here connected to the ground, the same as we have here, my friends. Do you see? Do you see here, my friends? We have 3 ceramic capacitors. Okay. What we will draw right now, my friends, based on one comment of one of my followers, Uganda, that told me I want to explain to me how to draw schematics just by taking a look to the motherboard. Easy. We will begin with 3-volt, 5-volt. We will see also how to draw RAM circuit, CPU circuit, or circuit. So I will just look to the motherboard. What we have here? We have the input, 3 ceramic capacitors. We have 2 MOSFETs. We have coil, 3 ceramic capacitor in the input, MOSFETs, coil. We will get output, and we have in the output, we have electrolytic capacitor here, and of course we have the IC. Nice. So let's continue. So 3 ceramic capacitors, my friend, in the input. Okay, and of course the source of this one will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. These 2 MOSFETs basically are controlled by this IC. We called it the 3-volt, 5-volt control IC. Okay, so here, my friend, the B plus, basically it's 19 volt, will pass through this ceramic capacitor in order to be filtered, and then will be present here in the MOSFET. So here 19 volt, here we will get, here my friend, we will get 3.3 volt. Why here we have 19 volt and here we will get 3.3 volt? Why? Because of this control signal. This is the controller that controls the MOSFET. Okay, my friends? The same, and of course after that the 3.3 volt will pass through this inductor here. Basically these 2 components, the coil and the inductor, are here for filtering, to filter 3.3 volt in order to get here a pure and exact 3.3 volt in this side. The same, my friends, the same for 5-volt circuit. We have the IC, we have 2 MOSFETs or 2 switches basically. So Q1, Q2, Q3, and Q4. The drain also will be connected to 3 ceramic capacitors. As you can see, 3 ceramic capacitors connected to the ground. Here, of course, here we have B plus, the same input basically, my friends, 19 volts. And these two B plus, my friends, coming from where? Coming from, do you remember when I told you that we have two switches in the input, and then we have the current sense resistor, or CSR, current sense resistor, and here we will get B plus, and I told you that this B plus will be distributed to all circuits. Yes, this is it, my friend, distributed to all circuits. Okay, so this B plus, if for example in the 3 volt 5 volt circuit you didn't find here B plus 19 volt, you should go here and check current sense resistance, is it good or not. Check the MOSFETs until the adapter or the power jack. Okay, nice. So the source of this one, my friend, will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. The two MOSFETs also are controlled by the charge IC. So the same 19 volt, my friends, will pass through these ceramic capacitors to be filtered, and then will be present here, will be applied to this MOSFET. We will get here 5 volt. Why? My friends, here we have 19 volt, here we get 5 volt. Why? How this is happen? Because of the IC, because of this control signal. That's why, my friend, I told you what do you know the name of this I forget this tool that we use for water. Here, for example, we have water, a lot of water. Enter here, a lot of water, my friends. Okay, but here we get just a little bit water here. So here this lot of water is 19 volts. Here basically this is the gate, and here we will get 3.3 volt. What we called this? Guys, can you tell me please, this tool for water, we called it what? Okay, let me check the traduction. Guys, let me check traduction. Again, so my friend, we call this faucet. Okay, we called this one, we called it faucet. Okay, we have 19 volts, the same 19 volts. We get here 3.3 volts because we use this gate here. This is the gate. If we turn this one a little bit, we will get 5 volts. If we made another turn, we will get 8 volts, for example. Another turn, we will get 12 volt. If we turn it until maximum, we will get 19 volts. Okay, this 19 volt will be also here, but just a little bit, we get 3.3 volt. This same working principle used with 3.3 volt IC. Right now, my friends, let's dive into CPU circuit. Sorry, my friend, billboard mic again, sorry. As I told you, my friends, always for live streaming, always no editing, no back off, always just we can deal with any problem, no problem. So, guys, CPU circuit. Let's begin first with RAM circuit, okay? RAM circuit first, RAM circuit, okay? And then pass to the CPU circuit. Okay, let's see a motherboard. Just take a look to the motherboard and done. Let's take, for example, my friend, this motherboard, the same working principle for all motherboards. For this motherboard, we have the CPU, we have two coils, the first channel, the second channel. This one is VCCP, not for VCC core. Those are for VCC core. We have two MOSFETs here, two MOSFETs. So for each channel, coil, two MOSFETs, coil, two MOSFETs. In the other side, ceramic capacitor into input, ceramic capacitor into input, and in the output we have 10 ohm capacitors, or it could be electrolytic capacitor. So let's see right now the CPU circuit. Remember, please remember the component. Let's see even another motherboard, always the same. We have the CPU, two coil, MOSFET, two MOSFET for this channel, two MOSFET for this channel. We have ceramic capacitor in the input, and if we go back for this, basically for this CPU, we have four MOSFETs, as you can see. Two MOSFETs here and two MOSFETs in the back. Two MOSFETs here, so four MOSFETs for each channel, and we have the IC, and we have 10 ohm capacitors here. 10 ohm capacitors in the output. Let's draw it right now, my friends. Basically, I will draw for you a simple CPU circuit with two MOSFETs, okay, and another CPU circuit with four MOSFETs like this one, four here, and we have four here. Okay, so let's do it, my friend, right now. The mic is good. Okay, the tap, thank you. Look, billboard, tap, yes, tap or faucet. Thank you very much. So let's, the mic is good. Let's dive in. Oh no, normally RAM circuit, I show you the CPU circuit, but here we have the RAM circuit. So let's make like this and CPU circuit. Okay, for the CPU circuit, guys, attention please. This is the most complex channel in the motherboard. That's why it deserves your attention. The most complex chart in the motherboard, it deserves your attention. Okay, we have here the CPU IC. CPU IC. Okay, the CPU IC, nice. Normally here we have one channel. Let's make like this. We have here one channel, my friend. Okay, to get here what? To get here the plus VCC core. This is the first channel. And over here we have another channel. Let's structure first the channel. To get what? To get the same voltage plus VCC core. Basically the two channels are connected, my friends, 2 channels. But here we don't have just IC like 3 volt, 5 volt circuit. No, my friends, we have also here the CPU itself. The CPU itself. Okay. Why we have the CPU here, my friends? We have the CPU because each CPU have an exact voltage, a voltage, let's see, reference. Each CPU has an exact voltage. So the CPU always send, we called it IDs, CPU IDs, about 7 or 8 signals like this, 1, 2, 3, 4, 5, 6, 7, 8. The CPU send the signals to the CPU IC, and based on the CPU IDs, the CPU IC, we know that, for example, the CPU is powered by 1 volt. This CPU, but another CPU, it could be 1.1, and basically the range is between 0.7 volts, okay, for VCC, let's say like this, to 1.2 volts. Let's see here, we have here what? We have plus VCC core, guys. Okay, so for this CPU, for example, plus 1 volt within the range. Good. So once the CPU IC receive this identification signals from the CPU, it will then generate the VCC core. But we need here, guys, we have 2 channels. We need here basically the first MOSFET, Q1, the second MOSFET, Q2 for this channel. Okay, this MOSFET basically connected to ceramic capacitors. Basically, we can find just 3 here or more, and those connected to the ground. And here we have what? We have B plus. Always the hero here is B plus, my friend. The hero voltage is B plus. Always B plus. The input. So here we have the input. So then here the source here will be connected to what? To the drain of this MOSFET. And then this MOSFET, its source will be connected to the ground. And here we have gates. Here we have basically the gate, it will be controlled. And this one also will be controlled with this IC. This is for first, basically, channel. And of course, here we have basically, guys, we called it phase. I will teach you the meaning of this phase. Okay, this is for the channel. Here, of course, we have, as we have seen in the motherboard, it could be many capacitors, many polarized capacitors, not just one. It could be 2, it could be 3, etc. Always connected to the ground. For the first channel, the same working principle. We have Q3, we have here Q4, okay? So the drain of this MOSFET should be connected to what? To what, my friend? To the same B plus, okay? To the same B plus here. And then its source, okay, will be connected to the drain of this MOSFET, and then the source of this MOSFET will be connected to the ground. And then, of course, here, as you can see, this one will be connected to the IC. And this MOSFET basically also will be what? Will be controlled by the same IC, as you can see, my friends. This one also we have here L1 first channel, L2 second channel. Here, basically, my friend, also we have ceramic, or this is basically tantalum capacitor or electrolytic capacitor connected to the ground. Okay, so this is the first channel, and this is the first channel, this is the second channel. The purpose is to generate plus VCC core. This is the purpose. So this is a simple CPU circuit. Okay, guys, let's draw a very complex CPU circuit, very complex one. Okay, so please hit the like button. I need more likes to draw for you the most complex CPU circuit that you can find in motherboards. Very complex, and I will show you, even if it's complex, I will show you how to deal with it and what is the most failed component in it. Let's draw it right now, my friends. The most complex CPU circuit that you can find ever. Okay. Okay. Same. We have first here the CPU. I will a little bit make here things smaller. We have the CPU. Okay, my friends. And here we have the IC. CPU, IC. And over here we have driver. We called it driver. This driver is a small IC. This driver is not like this IC, but a small IC. I will show you this kind of driver in the motherboard. Here we have the second driver. For this driver belong to the first channel. For this driver, it has basically 4 MOSFETs. Not 2, 4 MOSFETs. For this driver also, it has 4 MOSFETs. This is the most complex channel, CPU channel that you can find. And of course, I will check the motherboards here and show you this kind of channels. Okay, so, and of course, here we have, let's see, here we have inductor. Okay, okay, here we're gonna connect everything. Don't worry, my friends. Plus VCC core. This is what we want to generate. Here also we have inductor like this in order to generate the same voltage plus VCC core. Good. So the CPU will send IDs like those. Will send CPU IDs, my friends, about 8 IDs. We call it CPU IDs or VIDs. Okay, my friends? Based on this ID, let's say the CPU is powered by 0.9 volts. Okay, within the range. 0.9 volts within the range, my friends. Good. I will show you these IDs on motherboards. Please, before continue drawing this schematic, let me grab a motherboard and show you the IDs in order to be sure and to understand, and of course the proof. What is the proof? I will show you the proof, my friend. Now I will show you the proof. Give me just 1 minute to look for a motherboard where IDs are clear. Okay. Of course, I will not deactivate the mic in order to avoid problems. Okay, now my friends, I look for IDs. Just 1 second. Let me see. Okay, I find it. I find it, my friend. I find it very fast. Okay, find it very fast, my friends. You see, my friends, here this is CPU circuit. Basically this CPU, even if it is old, guys, please, even if the motherboard is old, but the same working principle. You can check your motherboard, you will find IDs. This is the CPU circuit. If I go here to the back, okay, this is the back of the CPU circuit. Do you see, my friends? Check here, my friends. Do you see here? Okay. The problem, the zoom out and in problem. Let's do like this. I hope. Okay, like this. Okay, good. Do you see, my friends? This is basically the CPU circuit. Here I have the CPU circuit. Okay. Okay, like this may be good. Okay, this is the CPU circuit, my friends. This is the MOSFET tantalum. This is the tantalum capacitor in the output. Here I have the CPU circuit. Do you see, guys, here? Do you see those test points? We have 1, 2, 3, 4, 5, 6. Okay, we have 7, 8, 9, 10, 11. Because this point is not connected to this. We see the trace here, go here. So those basically, my friends, are IDs. Those basically are coming from the CPU. Those, the IC receive those IDs in order to generate here. This is the input, this is the output. It receives this IDs exactly as those. Like those, my friend, in order to generate VCC code. I hope that you understand. I'm sure you understand. Please, my friends, just 1 minute. Did you ever know, did you ever watch like this kind of videos? Like this kind of knowledge? Did you usually someone has explained like this, or this is the first time? Okay, I will go back to the comment after. Let's first, my friend, let's first continue and completing this very complex schematic. So here we have drivers. So this driver basically are connected to the IC. So the IC here control the driver, and then the driver control those MOSFET. Okay, the same gate. And of course, those MOSFET, the drain here, as you can see, all drains here are connected, and here you can find many ceramic capacitors like this. And here we have what? We have the B plus here. Here, my friend, we have the B plus. So the B plus will be applied to these capacitors that are connected to the ground, and then applied to this MOSFET Q1, Q2, and the source of this MOSFET will be connected to the drain of this MOSFET. The source of this MOSFET will be connected to the drain of this MOSFET here, and then this MOSFET will be connected to the ground, and of course the source of this MOSFET also will be connected to the ground, Q3, and here we have Q4. And of course here we will get, my friend, here of course always connected to the IC in order to correct the voltage. Here we have L, here we have capacitors. Okay, basically it could be 3, 4, etc. connected to the ground. The same, this is the first channel, my friend. For the second channel, the driver also will be controlled by the IC, and the driver also will control this MOSFET and this MOSFET, and also control this MOSFET and this MOSFET. The drain of this MOSFET is connected with the drain of this MOSFET, and then connected to what? Connected to the B plus, always B plus, the main voltage. This B plus basically, my friend, is coming from where? Is coming from the current sense resistor, the CSR. Okay, coming from the current sense resistor and divided to all circuits in the motherboard. Okay. So we have here Q5 and Q6. The source of this one will be connected to the drain of this one, and then the source of this one will be connected to the ground. The source of this one will be connected to the drain of this one, and then the source of this one connected to the ground. Here we have Q7 and Q8. And of course, we will get here, we have here basically the, let's say L1, L2, L3, L4. Here, of course, we have tantalum capacitor connected to the ground, and then we will get plus VCC core. So this is basically, this one is basic, is normal. This one is a little bit complex. The failure here is easy, simplified. It could be IC MOSFETs or capacitors or serum capacitors into input. Okay, but this one we have driver, we have more other MOSFETs. This basically here, 4 MOSFETs here and 4 MOSFET here is the same, my friends, is the same as this one here. We have 4 MOSFETs. Also, we have here 4 MOSFETs and 4 tantalum capacitors. Okay, I'm going to show you, my friends, what is the most common failed component in the CPU circuit. But first, how the voltage is passed through the ceramic capacitors. So here we have B plus basically 19 volt. It will pass through, okay, 19 volt, pass through these ceramic capacitors to be filtered. It will be applied here to this MOSFET. The MOSFET, basically the CPU will control the driver. The driver will control this, guys. Basically, this driver, guys, is used here just to make things very accurate, because for the CPU, always we have more components. Why? Because we need a very pure, exact voltage, 100% exact voltage for the CPU. So here we have 19 volts. Those MOSFETs will be basically controlled by the driver and the IC to get here how much? 0.9 volt. Here we got 0.9 volt. Why? Using the faucet rule. Using the faucet rule, my friend. A lot of water, we get here, we have 19 volt, we get here 0.9 volt. 0.9 volt. Faucet rule, my friends, or the tap. Okay? And then here 0.9 volt will pass through coil with capacitor for filtering. And then we will get VCC coil. We have another channel. The first channel here and here we have the second channel. Why basically we have more channel? Just in order, this channel works, for example, for 3 milliseconds, this one works 3 milliseconds, and switching work, okay? It's a shift work, because all the CPU needs a consistent voltage. That's why we have more channels. So guys, this is it for the RAM. Let's finally let's see the RAM, and I will stop. Of course, I will. Let's draw the RAM circuits easy, and then read comments, and then stop. Okay, my friends. Okay, let's draw the RAM circuit. RAM circuit. Easy for the RAM circuit. We have the IC. Okay, we have IC. RAM IC. Easy. It will receive basically the inputs, and the output will be applied to basically 2 MOSFETs. Okay, Q, the same working principle. This MOSFET will be connected to what? It will be connected to B plus, sometimes to B plus, sometimes to 3.3 volt, and sometimes to 5 volt, depending on type of the laptop. Okay, my friends? Of course, here always we have ceramic capacitors connected to ground in the input, the source connected to the drain, the source connected to the ground. Here controllers by the IC. Okay. So here we will get the voltage. The voltage here for the RAM, the VRAM, depending on the type of the RAM. If the RAM is DDR5, the voltage will be 1.1 volt. If the RAM is DDR4, the voltage will be 1.2 volt. If the RAM is DDR3, the voltage will be 1.5 volts. If the RAM is DDR4, the voltage will be 1.8 volts. And let's see DDR5, DDR how? DDR5, DDR4, DDR3, DDR2, and DDR1, 2.5 volt. Not use it, not use it. Use it a little bit, use it. This is the used one, DDR5. Okay. So here, depending on type of the RAM, we will get here plus VRAM. If we say the RAM is, for example, DDR5, we will get here how much? 1.1 volt for the RAM. Of course, here also we have capacitors, electrolytic capacitors for filtering and inductor. But for the RAM, this voltage basically 1.1 volts. Okay, 1.1 volts here, this one, my friend, will be applied to another IC. We called it divider. In order to get what? To get the half divider divided by 2, and then we will get 0.55 volt for VTT. Okay, my friends? Sometimes we can find two IC, but sometimes we can find the same IC generate 1.8 volt and generate also the VTT divided by 2. I hope that you understand, my friends. I hope you understand. We have basically discussing 3 schematic: RAM circuit, CPU circuit, and charge circuit, and also 3 volt, 5 volt circuit. Please, more likes for the video. Now I'm going to check the comments if I find a question, and it's enough for today. About how many hour? Okay. So, okay, I will say the comment, my friends. I will say the comment. I will answer if I have a question here, and then we will stop the live. So please like and share, and hit the bell icon for future and upcoming videos and lives. Okay. Okay. Please, my friend, if you have any question, post it in the comments. Any question, I'm here to answer. Okay. 1 minute, and then I will begin answering your comments. Okay, let's get started. Let's see what we have here. Okay, we stop where? Okay, okay. Free MPS TV. Good question, Albert Jara. Okay, now we stop where? Okay, nice work, brother. Yes. Okay, we stop in Uganda. That ask me about, is it possible you make the drawing from all the circuits in the board? I like it how you explain. Okay, let's continue. Question and comments. Free MPS TV, can you talk about voltage injection? I told you, brother, that yesterday we have seen in the yesterday live the how injection is done. Okay, frame PS TV, what are the major faults that caused the motherboard? My friend, I note your question. So for tomorrow, I will answer you, my friend. Okay, for tomorrow, I will answer you, and this is the proof. Your question, my friend, is here. The most major faults did motherboard for tomorrow live. My live streams and my videos, my friend, is based on your comment. That's why please don't hesitate to comment in videos, in live, etc. Okay, let's continue. Albert, good question. I answer Mr. Alexander Luis. Please, I have a laptop HP Pavilion. It's not charging. I answer you, my friend. Check on the Epson why my laptop, the arrow isn't moving soon after switch on, but it starts move after press any button. Maybe if you mean the mouse, it could be the charger, the adapter. The current is not enough, my friend. Use another adapter, use a suitable adapter, and you will fix the problem. Albert, what time are you leaves? Now, my friend, the time is, let me say, this is basically 8 p.m. 8 p.m. here in my country, 8 p.m. Alberts, how can you tell, or how do you tell when a big UIC chip is bad? Okay, always ICs we check the ceramic capacitors around it. Tabo, I'm enjoying. Thank you. No audio, no audio. Bro, check your mic. Can't hear you. Sorry. I forgot the mic, my friends. Okay, sorry. We can imagine what he is talking. Sorry for the mic, my friends. Okay, frame PSTV, sometimes the two circuits are separated with two different ICs, each handling 3.3 volt and 5 volt individually. Yes, it could be. This could be. In newest motherboards, you can find two separated ICs. One IC, another IC generate 5 volts. Okay, it can be separated. One for 3.3 volt and the other for 5 volt. Continent C5 films. Does the second MOSFET queue to only work when the battery is powering the laptop? And does it simply prevent the battery current from reaching back to the Q1? Yes, absolutely, my friend. We didn't hear anything, sorry. The circuit doesn't only work on battery, it is also works on charge. Yes, my friend. Basically, the laptop could be work using the charger or the battery. Okay, and of course, okay, I will. Let me. Of course, my friends, when the laptop powers using this one, the adapter, here you can find 19 volt here, but 19 volt will not pass to the battery. Also, this one protects the battery. But when the laptop works using the battery, here, basically this one you will find here 12 volt and here 12 volt, but the 12 volt will not pass to this side. This one also is protect this side, and this one protect this side. When using the charger, this one protect the battery. When using the battery, this one protects the other components. Okay, for MPS, we will need to take us through VCC core. Today, I explain to VCC core and VCCP. We can do a separated video or live for these two voltages. Thank you, Oli Wafimi. Hi, ARB, hi. Yes, thank you. C5 films, the water control device is a faucet or tap. Thank you very much. This faucet is the same working, or the charge IC with the MOSFET are same as faucet. Continent, C5 films, bravo, buddy, have sent you a small gift. Thank you. C5, Continent C5 films, this is one of my best followers. It always present, and also Oli Wafimi and of course others, Frame PSTV, Albert, a lot of friends are always present with me. Okay, and thank you, Mr. C5 Films. You are one of the faithful followers. Thank you very much. I appreciate that. Which circuit uses the VCC core and how different is it from VCCP? I hope I explained to you, my friends, VCC core. If you join right now, just go back, you will find the explanation. And VCCP is basic. VCCP is also another IC without MOSFET, sometimes without MOSFET, that generate VCCP 1.05 volt. No, my friend, frame PSTV, does it mean VCC core is always 6 volt? 6 volt? No, VCC core. You mean 0.6 volt and 1.3 volt? Yes, it's right range, good. VCC core is very low, especially for newest motherboard. The VCC core is about 0.6, 0.7, but for old motherboard 1.2, 1.1. Okay, frame, PSTV, what are the function of VDD and VTT voltages? Which one is actually used by the RAM? So the main voltage or VDD is the one used by the RAM, okay? But for VTT, my friends, for VTT basically is for termination or for communication to transfer data. But some boards also basically use another voltage, 1.8 volts. Okay, let's see. Albert's, okay, I am in Chicago. It's 2:30 p.m. here. Sorry, my friends, but the live will be saved. Don't worry. I always save the live streaming in order to be viewed or watched by other friends like Albert to 2:30 p.m. late. Innocent, I really enjoy the contents when I inject the keyboard on the motherboard of the Inspire laptop. It's shutting off the laptop. What can be the issue and how to fix that? Thank you. I really enjoy the contents when I inject the keyboard on the I didn't understand, my friend. Oniji, I'm watching from Nigeria, Abia State. You are very welcome, all of you, my friends. Free MPS TV, I think he is talking of the Q1 and Q2 of the 3.3 volt and 5 volt circuit. Okay, for the 3 volt and 5 volt circuit, Q1 and Q2, the two MOSFETs are used to generate 3.3 volt. And they work in a shift. They are switched. The lower one basically is used to protect the circuit. The lower one is used to protect the circuit. When, for example, there is always, my friend, this lower MOSFET connected to the ground, if there is any high voltage, high current here, something not correct here, it send it to the ground to protect the circuit and to adjust the output voltage. So this is, my friends, I read all comments. Thank you very much. I appreciate your comment. I appreciate your presence. I hope that you understand. Thank you very much. Please don't forget to like, subscribe, share, hit the bell icon for upcoming videos, live stream, and also for anyone who has the possibility of sharing my channel and these videos with others. I appreciate that. Okay, Oniji, master, I'm beginning a laptop repair. You are very welcome, my friend. Just check your channel, go to the homepage, click videos. You will find about more than 500, maybe 550 or more videos. Enjoy my channel, a lot of videos. This channel basically for anyone who follow me in this channel, I'm sure you will be a professional. You will deal with any field. Okay, just continue with me, continue learning step by step. Okay, my friends, and of course for anyone who want to accelerate learning for more unique content, download schematics, you can join me in my Patreon page. Check my website. All links in the description. You will find all links in the description. Thank you very much, and see you on other live stream, other videos. And please don't hesitate to tell me in the comment if you have suggestion. What is the next topics to study, to discuss? You are very welcome. I always I always use your comment, your questions to generate and to upload more content for you. Okay, that's why the comments are very important, especially when there is a good question or suggestion. So thank you very much, guys. See you in the next live stream.